sorry, you have reached a number that has been disconnected or is no longer in service.
Welcome to another episode of the Bug Bite, hosted by yours truly, Tech Coach Ralph, where we are engineered to win. In today's episode, we are going to hop into our time machine to go back in time. We are going to be reviewing an AT&T software defect from 1990, which caused the entire AT&T network to go down. So, without further ado, let's hop right into our story of the day. Alrighty then. So, the first article we're going to be reviewing is from January 16th, 1990, written by John Burgess. And this story comes in part from the Washington Post. Yes, the Washington Post. It has been around since forever. Okay. So let's not waste any time. Let's jump right into it. It says American Telephone and Telegraph Company long distance network, by far the nation's largest, suffered an unprecedented breakdown yesterday, blocking the calls of millions of people in communities coast to coast and disrupting many businesses. Through much of the afternoon and evening, only about half the calls dialed on AT&T got through, the company said. The system returned to normal by 11:30 p.m. according to AT&T, but its technicians still were unsure what precisely had caused the mass outage. Suspicions focus on the highly complex computer software that manages the network and on normal business days smoothly routes approximately 100 million calls. This is major, AT&T spokesperson Herb Lennon said of the nationwide system failure. There is no precedent to it in terms of length of time and the nature of it. He said technicians would study it closely until they understood it fully. They were doing troubleshooting and trying to see the root cause of the bug that caused this major system outage from coast to coast. All right. So it says, reaching into millions of homes, the failure appeared to be one of the most serious of the computer age in terms of scope of its impact. It is certain to refocus attention on ways to protect the economy and government against outages, deliberate or accidental. Of course, deliberate or accidental, of computer systems whose importance grows daily. You know, and it just shows back in 1990 how we were trending more and more towards being a technology led society. Now everything runs on technology. Like if this type of outage was to go out for just one cell phone provider, we would be in mass chaos. We would be thinking it might be some type of cyber terror attack or something like that. So I can, like, just from, like, what are we in now? We are in 2024. So, uh, 34 years ago, right? Is that right? Yeah, 34 years ago. We could see the impact of a telephone system going down, and this was like landline for the most part. So imagine now with all of our cell phone networks, our internet, if when we reviewed about the northeastern power grid going out, you see the chaos that causes. Right, the telephone network is becoming one big computer system," said Jerry Lucas, president of McLean Consulting Company Telestrategies Inc. A software glitch in one part of the system can literally take down the whole system. It can literally take the whole system down. And that's one of the things we talk about in software engineering and software development is about decoupling the system, trying the best as possible for one part, like for one glitch taking down the whole system. But sometimes, if the um software is the core dependency and everything flows through it, then it might be inevitable. But so maybe we'll find out what caused this as we keep reading. But we'll see. So AT&T's working assumption last night was that its problem was accidental and it played down suggestions that it was caused by a computer virus, a type of program designed to spread and replicate itself, and which saboteurs have used to immobilize other computer networks. And it's interesting that, so remember, this article is from 1990. So at the time in 1990, I don't for the most part, the general public did not know what a computer virus was, and that's why they deliberately explained what they meant by computer virus, right? So remember, we are back in time right now. We traveled back to the future to get a better understanding of what happened in this 1990 bug. All right. So now we're applying our understanding from 2024, but if we were in 1990 and we were hearing about a computer virus, would think like, well, why don't we just take the computer to the doctor, right? But there was no Geek Squad at the time to help troubleshoot this. So it was a virus, and can we give it some antibiotics or something? And quite frankly, you couldn't. All right. So let's keep going. All indications so far are that a virus is not involved. The first sign of trouble came about 2:30 yesterday afternoon when technicians at AT&T's National Control Center at Bedminster, New Jersey, noticed warning signs displayed on electronic maps. To stem the damage while experts searched for the problem, the control center reprogrammed the network to reduce the number of calls it would accept from callers. So he's like, well, we have a problem. Let's shut down our lines for these customers not to call in while we try to resolve it. Sometimes you have to do what you have to do. All right. Now, it says many AT&T customers got recordings advising them that circuits were busy and to try again later. All right. In some instances, AT&T operators accepted only emergency calls. Elsewhere, calls went through normally and subscribers were not aware there was a problem. All right. Some people didn't even notice it. They say, hey, we have a date tonight. Can I come pick you up? And it was like, yes, sure, of course. Right. And they had no idea that there was a massive outage, not caused by a virus, that was happening at the time. All right. International calls and the increasingly used toll-free 800 numbers were also tied up. So you could not call Miss Cleo for a free reading that cost $2.99 per minute. Nope, you weren't able to do that. So you saved some money that day at least, right? Although private lines that many businesses lease from AT&T were not affected. Oh, maybe you could still call Miss Cleo. Who knows, right? In general, calls to and from the Washington area were not as badly affected as other areas of the country because the politicians have to politicize. Is that a word? I don't know. Anyways, the main cost to residential callers was frustration. Yes, because we need to get our calls in because we need to know what time is dinner, where, we just need to know, right? But some businesses that depend heavily on long distance services were hit in the pocketbook. Oh, no. You cannot come after our pocketbooks now. Now, Houston, we've got a problem. Calls to American Airlines reservations centers dropped 75% to 80% below normal volume. So they had a day off. According to a company spokesperson, United Airlines reported calls down 50% to 60%. See, and interesting, isn't American Airlines and United Airlines now the same company? I think United Airlines bought American Airlines. I could be wrong, right? But back in 1990, they were two separate companies, apparently, right? This is fairly recent as well. Both said that airline operations and computer data lines, which run on private networks, were not affected. All right. Regional distributions of long-distance networks are a rare but not unknown occurrence, usually caused by the physical destruction of facilities by bad weather or by accidents such as construction crews severing high capacity fiber optic cable. So they even had fiber optics back then, all right? But just not for internet, okay? But this appeared to be the first national disruption with no apparent physical cause. AT&T said last night meaning in 1990, that the problem appeared to be centered in computer equipment the company began installing in 1987 in its 110 national switching centers. The program is supposed to be complete in 3 to 4 months, all right? So, it sounding more and more like there was some software testing issues that were not handled properly. All right? So, this the gear and accompanying software controls a signaling network that exists solely to set up and convey information about long distance calls. The conversations themselves are carried on a separate network. Other companies such as MCI Communications Corp have suffered minor disruptions in phasing in the same gear. Oh my goodness, I remember MCI when I was growing up. That was a very, very popular phone service company. I remember hearing commercials for it all the time, right? This equipment handles such functions as checking to assure a number dialed is not busy before setting up a voice circuit to reach it, thereby not wasting a line. It also conveys such information as the originating number of the call, making possible such new services as caller ID, in which a display shows the number from which an incoming call was placed. And now, if we did not we are shocked when we do not see the number who is calling us with the name of who's calling us and maybe even a state or country where we're getting the call from. But I remember growing up when there was no caller ID. You just answer and say, "Hey, who's this?" Right? Thanks for calling this residence. Who is it? How can I help you? And then once we got the caller ID, we could see who was calling. I'm like, oh, I'm not answering that. I am not answering that. Right. So that was when caller ID was introduced. And it was around this time, to be honest with you. Right. So the most complex software ever written in the world, bar none, is switching software at that time. I'm pretty sure there's a way more tougher software written now, said Frank Dubeck, president of Washington's Communications Network Architects, Inc. It can consist of millions of lines of code, the language that human beings type on computer screens to create programs that they hope will let the telephone system's computer know how to deal with every conceivable situation. Yep, at the time, it was probably one of the most complex back in 1990, but they did not have Facebook to compete with as the most complex software ever written. There was not Tesla cars that are electric to deal with. So at the time in 1990, possibly the most complex, but today we have Instagram as well as one of the most complex softwares ever written. And let's not even mention TikTok. That is software hell because it is so complex to upload those little dance videos or of your cat and stuff like that, right? So, anyways, let's move on. Bugs, yes, bugs or mistakes in software often come to light when a new program is first being used. That's a fact, though. In some cases, they lie undetected for years until a particular set of circumstances that the programmers did not foresee occur, causing the machine to freeze. Yep. So they had to break this down in 1990. What we've been dealing with for at least for my career, right? Dealing with bugs. Economic impact of yesterday's failure was lessened by the fact that many companies and government agencies use other long distance companies and that many of AT&T's institutional users were closed in observance to the birthday of Martin Luther King Jr. So even the phone lines decided to celebrate Martin Luther King Jr.'s birthday. Effects on government seem to be small. A White House spokesperson said last night that calls were going through just fine and dandy. Of course, it is at the White House. A spokesperson for the Federal Emergency Management agency said it was not tracking the problem. So FEMA was like, who cares? All right. MCI and US Sprint Co. Do you guys remember Sprint as well? Sprint is didn't go out of like didn't get bought out as early as MCI did. So the Sprint one is fairly recent. I don't remember. Are they with T-Mobile now? They merged with somebody. I remember Nextel as well. That was under Sprint. The number 2 and 3 long distance companies reported absolutely no problems on their networks yesterday. Sprint said that its volume of calls was up a bit as AT&T customers dialed special access code with each call to use Sprint's network. So they pivoted. All right. And it says today's competitive long distance system allows customers to use companies other than the ones with which they have signed up. Sprint, for example, is reached by dialing 10333 before the number being called. MCI's number is 10222 and AT&T is 10288. All right, we should try that. For AT&T, which has long depicted itself as the right choice in a market filled with unreliable companies, the incident brought major trauma. We've isolated some troubles in various equipment, said one AT&T technician late last night, but our network's still sick. It is still sick in need of antibiotics. Shortly afterwards, the company announced the system was again working normal. So that is the article from the Washington Post about the software bug, not a virus, the software bug that caused the AT&T network to be hit hard back in 1990. However,
Hello, this is a prepaid collect call from an inmate at Florida Correctional Institution.
there is one more article. I'm not even sure if it's an article, but there is one more page that I would like to go through together real quick, just so we can see what they also said about it. So let's just jump into it as well, and we will read that together real quick, not as long, and we shall wrap it up by getting a little bit more information about this software bug that affected AT&T in 1990. But before we do that, if you are enjoying this information so far, this breakdown, this bug bite review of AT&T's long distance network collapse, please subscribe to the channel, hit the notification bell so you can know every time we go live or drop new content. Like the video, share the video with a friend, and check out the Patreon at www.techcoachralph.dev so you can see all the exclusive content that I offer to my Patreon members so I can help them level up their technical skills and their careers. But without further ado, let's just jump right back into the next article. So this one says, all circuits are busy now. The 1990 AT&T long distance network collapse. All right. And this is by Dennis Burke. This is from Cal Poly EDU, so California Polytechnic State University. So let's read. My video might be covering a little bit, but it is what it is. I will read. I'll have this article posted in the description so that you can read it for yourself if interested. But you can just listen to me reading it. All right. So at 2:25 on Monday, January 15th, network managers at AT&T's Network Operations Center in Bedminster began noticing an alarming number of red warning signals from various parts of their worldwide network. Within seconds, the giant 72-screen video array that graphically represented the network was crisscrossed with a tangle of red lines as a rapidly spreading malfunction leapfrogged from one computer-operated switching center to another and another and another, and it was just a massive mess, right? But by the way, I would love to have the giant 72 video screen array as well. That would be very nice. I don't have space for it, but I would love to have it. All right. So it continues to say the standard procedures the managers tried first failed to bring the network back up to speed. And for 9 hours while engineers raced to stabilize the network, almost 50% of calls placed through AT&T failed to go through until 11:30 when the network's load. Oh my goodness, what is this? What is this? Come on, professor. Let's get this together, right? Anyways, until 11:30 p.m. when network loads were low enough to allow the system to stabilize, AT&T alone lost more than $60 million in unconnected calls. Still unknown is the amount of business lost by airline reservation systems, hotels, rentals, car agencies, and other businesses that relied on the network, on the telephone network. This wasn't supposed to happen. AT&T had built a reputation of a huge advertising campaign based on its reliability and security. What had gone wrong? So I remember those campaigns as well, right? So, um, on a good day, normally AT&T's long distance network was a model of reliability and strength. On any given day, including any given Sunday, AT&T's long distance service, which at the time carried over 70% of the nation's long distance traffic, routed over 115 million telephone calls. The backbone of this massive network was a system of 114 computer operated electronic switches, for ESS, scattered across the United States. These switches, each capable of handling up to 700,000 calls per hour, were linked via a cascading network known as a common channel signaling system, number 7. When a telephone call was received by the network from a local exchange, a switch would scan a list of 14 different possible routes to complete the call. At the same time, it passed the telephone number to a parallel signaling network that checked the alternate routes to determine if the switch at the other end could deliver the call to its local company. All right. So it was one thing happening on one side and then on the other side. So they said, all right, we need to see, okay, what's the route? And on the other side is checking to see, all right, if we send it to this switch, are you able to deliver the call? Right. So that's pretty much what's happening. All right. So let's keep going. If the destination switch was busy, the original switch sent the caller a busy signal and released the line. If the switch was available, a signal network computer made a reservation at the destination switch and ordered the destination switch to pass the call. After the switches checked to see if the connections were good, the entire process took only 4 to 6 seconds, which in today's age, that might be a very, very long time, all right? So, what went wrong with this process? It wook. Not sure what the word wook means, but okay. It wook only slightly longer to slow the entire network to a crawl. Working backwards through the data, a team of 100 frantically searching telephone technicians identified the problem, which began in New York City, the Big Apple, NYC. That's where it all began. It was all a dream, right? The network switch, the New York switch had performed a routine self-test that indicated it was nearing its load limit. It had enough. As standard procedure, the switch performed a 4-second maintenance reset and sent a message over the signaling network that it would take no more calls until further notice. We are closed for business today. After reset, the New York switch began to distribute the signals that had backed up during the time it was off. Across the country, another switch received a message that a call from New York was on its way and began to update its records to show the New York switch back online. A second message from the New York switch then arrived less than 10 milliseconds after the first. Because the first message had not yet been handled, the second message should have been saved until later. A software defect then caused the second message to be written over crucial communications information. Software in the receiving switch detected the overwrite and immediately activated a backup link while it reset itself. But another pair of closely timed messages triggered the same response in the backup processor, causing it to shut down also. When the second switch recovered, it began to route its backlogged calls and propagated the cycle of closed time messages and shutdowns throughout the network. The problem repeated iteratively throughout the 114 switches in the network, blocking over 50 million calls in the 9 hours it took to stabilize the system. All right. So so far sounds like a race condition is happening, and because something was backed up, it tried to send information over and over, and it was just a hot mess. All right. So the root cause of the problem. The cause of the problem had come months before, so it was there for a while. In early December, technicians had upgraded a software to spread processing of certain types of messages. Although the upgraded code had been had been rigorously tested, a one-line bug was inadvertently added to the recovery software of each, not of one, of each of the 114 switches in the network. So it was rigorously tested, but there was still a one-line bug. Most bugs are one line or one letter. It's what happens. All right, it's what happened. The defect was a C program that featured a break statement located within an if clause that was nested within a switch clause. This makes total sense to me, right? We're gonna break it down, especially if you understand code. In pseudocode, the program reads as follows: while ring receive buffer not empty and side buffer not empty, then do this. Initialize pointer to first message in side buffer or ring receiver buffer. Get a copy of the buffer, switch. So now here comes the switch statement, right? Switch the message in for the case of incoming message. If sending switch is out of service, do. If ring right buffer is empty, then do this. Send in service to status map, else break, right? So the break is happening on this, right? And then we have this end if right here. And then this if statement. So this if statement, it says process incoming message, set up pointers to optional parameters, and then break and switch and then do optional parameter work, right? So it says when the destination switch received the second of the two closely timed messages while it was still busy with the first, buffer not empty, line 7 here. The program should have dropped out of the if clause of line 7. Instead, because of the break statement in the else of 10, because of this break statement, the program dropped out of the case statement entirely and began doing optional parameter work, which overwrote the data line 13. Error correction software detected the overwrite and shut the switch down while it could reset. So many typos in this, Jesus. Because every switch contained the same software, the resets cascaded down the network, incapacitating the system. So let's take a look at it, right? So if you are in here and this breaks, So because it came here, it broke here, it jumped to here. While they were intending to break, if this happens, or if this doesn't happen, then break out of this if statement. Interesting. Okay. So what were the lessons learned from this incident? Unfortunately, it is not difficult for a simple software error to remain undetected to later bring down even the most reliable systems. The software update loaded in the 4ESSs had already passed through layers of testing. ADN had remained, oh my goodness, and had remained unnoticed through the busy Christmas season. AT&T was fanatical about its reliability. The entire network was designed such that no single switch could bring down the system. The software contained self-healing features that isolated defective switches. The network used a system of paranoid democracy where switches and other modules constantly monitored each other to determine if they were sane or crazy. Sadly, the January 1990 incident showed the possibility for all of the modules to go crazy. It made the modules go crazy at once. How bugs in self-healing software can bring down the healthy systems and the difficulty of detecting obscure load and time-dependent defects in software. That is totally true. Deal with that every single day. However, what happened was because of the bug that and they installed it on all the switches, it ended up infecting all the switches. So very interesting to see. And to wrap it up, it says there is still much to be learned from this incident. However, clearly the use of C programs and compilers contributed to the breakdown. Oh, now we're blaming the language, huh? Okay. A more structured programming language with stricter compilers would have made this particular defect much more obvious. The routine practice of allowing the long distance switches to shut down and reset themselves also contributed. A more fault-tolerant hardware and software system that could handle minor problems without shutting down could have greatly reduced the effects of this defect. The final lesson is a positive one, however. It is worth noting that with AT&T's careful attention to hardware survivability and extensive testing, this is one of the few problems ever to impact their long-distance network so severely. While the break statement flaw could have been avoided with more thorough software engineering techniques and testing, many more problems have already been deterred by the system in place. The AT&T long distance system stands out not just as software engineering example, but because of its rarity. So that is I guess we'll call it an article from this professor. Is it a professor? At California Polytech State University, written November of 1995. So that was very, very interesting to read through. I learned a lot about this defect, and seeing how the same issues that we face today also go back. And you know what? Just making me think about it now. I think that as like if you are a Q engineer, I think it's important that we should start to look a little bit more into the code. I know a lot of times we're just we're supposed to be doing like functional testing, maybe load testing, stuff like that. But giving a quick look at the code, looking at the if statements, seeing, understanding if they are being handled correctly, like switches, loops, and stuff like that. Maybe we should start looking into unit tests as well to see like, okay, what are your unit tests covering all the conditions? Because a lot of times developers do not have that testing mindset, and we can play a big role in making sure that all of the cases are covered. That's my thought. I've thought about that for a while, but maybe it's time that we start making a higher concerted effort on it. All right. But that is the episode of the Bug Bite today, where we went back in time, but we are going back to today and we are going to be moving forward. So I would like to say thank you for tuning in to this episode of the Bug Bite. If you enjoyed the show, please do not hesitate to click the subscribe button, hit the notification bell so you can know every single time we go live, like the video and share the video with a friend. Check out the Patreon at www.techcoachralph.dev, where you can level up your technical skills. But on that note, thank you for tuning in. This is Tech Coach Ralph, where we are engineered to win, signing off on another episode.
If you enjoyed the fascinating information shared in this video and you want more, be sure to hit the subscribe button to Tech Coach Ralph to be notified for new videos.